All right, folks, let's get started. Topic of today's video, what is trigonometry? Well, that's a good question, and it has a good answer. The story of trigonometry all begins with an ancient mathematical wizard named Trigonometrius. It also begins, as does every other story, with similar triangles. Let's see. Okay, let's suppose that we have two triangles, and let's say that they're both right triangles. So they both have a right angle, right down here, right down here. Let's also say that they share another angle, and we're going to call this theta. Yeah, this little oval with the line through it, that's called theta. It's a Greek letter, don't be afraid. Well, these triangles have two angles in common. So we know, again, elementary geometry, angle means that these two triangles are similar. What else do we know? We know that when two triangles are similar, their corresponding sides are not necessarily equal, usually not, but they are in proportion. Okay then, so let's write down some of these similarity ratios. Well, one of these ratios is that this side to the hypotenuse, so this side which is opposite the angle theta to the hypotenuse, must be equal to this side to the hypotenuse. Little b times little c equals capital B times capital C. Okay, so that's the first similarity ratio that we have. Well, the second one, we could say the same thing about little a, little c, and capital C. So here's the second similarity ratio. And for a third similarity ratio, well, we can say that little b to little a is the same as capital B to capital A. So little b to little a, capital B, capital A. As I mentioned earlier, these three equalities were first observed by Trigonometrius centuries ago. So if you have any two right triangles that also share an angle theta, it's not necessarily the case that the corresponding sides are the same. As you see, this side is much bigger than this side, but the ratios are the same. And Trigonometrius thought that this was such an important observation, this key fact about similar triangles, that he granted these three ratios special names. The first of these he called sine theta. Remember, theta is this angle here, and these ratios only depend on that angle. The second he called cosine theta, and the third he called tan theta. Now, why did he choose these three names? Nobody knows. It's a magical mystery. But this is what they are called: sine, cosine, tangent. Now, these three ratios, they're a little bit hard to remember with A, B, and C. So Trigonometrius also developed a magical incantation that allows us to remember these ratios. It's called SOH-CAH-TOA. Let me show you. So this is the magical incantation invented by Trigonometrius. SOH-CAH-TOA. SOH-CAH-TOA. Now, what do these mysterious letters mean? Well, Trigonometrius decided that instead of calling the sides of a right triangle A, B, and C, we're going to refer to them by how they relate to this angle theta. Okay? Well, this side already has a name. We know the longest side of a right triangle is called the hypotenuse. This side here is next to the angle theta, but it's not the hypotenuse. Since it's next to the angle theta, Trigonometrius decided to call it the adjacent. Adjacent is a fancy word for next to. Well, what about the side opposite angle theta? Well, he decided to call it the opposite side. Very creative. But what about SOH-CAH-TOA? Well, this mnemonic device allows you to remember those three trigonometric ratios we described earlier in terms of these sides. So it says sine of theta is opposite over hypotenuse. So sine of theta is the side opposite angle theta over the hypotenuse, the longest side of the triangle. CAH. This says that cosine of theta is, you guessed it, adjacent over hypotenuse. In other words, cosine of theta is the side next to theta, but not the hypotenuse, over that hypotenuse. And finally, tan theta, well, that's just opposite over adjacent. So that's the side that's opposite the angle theta over the side that's next to it, but not the hypotenuse.